Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 399, evaluate division. It's a really interesting problem. So basically what we're given is we're given a list of equations. Each equation item contains two variables like AB, BC, AC, and so on. And the values array represents the quotient of each equation. So for example, if the first equation is AB and the value says 2, that means A over B is 2, and so on. And then given this, we're given a list of queries. So we're given, okay, evaluate AC, right? So we know A over B, we know B over C, so we can evaluate A over C. And then the other one says like evaluate BA. So since we know A over B, we can also evaluate B over A, and so on. And if we're not able to evaluate it, let's say X and X, right? We don't know these variables. We are going to then return -1. So how do we approach this problem? So if you think about it, this is basically kind of like a graph problem, right? Because we have to keep chaining the divisions until we reach our desired variable. So let me show you a bit what I'm talking about here. So let's say we know A over B is equal to a certain value, right? Let's say this is equal to 5. And let's say we know B over C is equal to a certain value. Let's say that's equal to 6. So then we can solve A over C by simply doing A over B times B over C, right? And that will be equal to, because the B's will cancel, and that will be equal to 30, right? So basically the way we can represent this, if we have a source variable, let's say X, and a destination variable Y, we have to keep traversing the possible quotients of X until we reach Y, right? So A over B, B over C. Let's say if there was like C over D, E over F, or sorry, D over E. So we can keep traversing this until we find the source and the destination. So this basically is a graph problem, and it's a bidirectional graph also, because if we go from, if we know D over E, we can always say that E over D is the inverse of that, right? So the 1 over the quotient, right? So we can also then reverse this and go from E to A if we were to solve for E over A, right? So let's draw the graph and see how that looks like. So let's say we were given that A over B is equal to 5 again, and B over C is equal to 6, and maybe B over D is equal to 2, right? So then we can draw a graph saying from A, right, we can go to B, and this is 5. B going to A is 1 over 5, right? So it's like a double graph. And then from B, we can go to C with 6. So we can draw here a node C, and this will be 6. And then from C going to B will be 1 over 6, right? And then from B, we can also go to D. So we can draw an arrow to D saying that B over D is 2, and then D over B is 1 over 2, right? So once we have this graph, bidirectional graph, right? So this is a node, this is a node, and these two are also nodes. And so now let's say we have a query saying give me A over D, right? So we go from A to B, we have 5, B to D, we have 2. So we just multiply everything along the path. So we have 5 times 2, that will be 10. And let's say we were to solve for C over A, right? So we start from C, we go to B, and then we try both the edges, so until we reach A, right? So we'll have, the path is from here and here, and so we'll multiply everything along the path. So 1 over 6 and 1 over 5, so that will be like 1 over 30. So yeah, basically at a high level, the step 1 is to create this graph, and then step 2 is to use the queries to traverse the graph. And obviously if we don't find the variable that we're looking for, we'll return -1, right? So let's go ahead and code that and see how it looks like. So first, let's initialize our map, which will hold the variable to the destination to the quotient, right? Now that we have this map, let's go ahead and populate the map based on the equations and the values that we have in our input. So let's create a loop to go through all the equations. So here we have our loop. Now we'll just grab the necessary variables. So we have the first variable equations get 0, the second variable equations get 1, and then the quotient will be, the values at I. Now we just have to fill in the bidirectional graph on the map. So here we have it. We are putting first an empty hash map just to initialize A and B. And then for A over B, we're putting the quotient that we got from the values array. And then for B over A, we're putting 1 over quotient. So now this will create our basically the graph structure that we showed earlier. Now let's just go through our queries and try to traverse the graph. So we'll create a loop that goes through all the queries. So here's our loop that goes through the queries. We'll also initialize our final answer array, because here's where we'll store all the answers for our queries, right? So we have that, and then at the end, that's what we'll be returning, right? Now, in here, let's first grab the two variables that we need to search for. So here are our two variables. We just grab the ith query and get 0 and 1. So basically, we'll need to search for A to B. And then we'll delegate this to a recursive function. So we'll say answer at I equals, compute A over B. So we'll basically ask this recursive function to compute A over B and also pass it the map or the graph, right? And to keep track of the recursion, we'll need to have a hash set that represents elements we've already seen, right? Just so we don't go back to the same variable in case there are any cycles in the graph, right? Because you can say A over B, B over C, and then what if there's a C over A as well in the equations? So just to avoid cycles, we'll keep track of what we've already traversed using a hash set. And then we'll have to initialize our product, right? So because as we go through the graph, we'll be multiplying along the path. And so the initial product will be 1. And as we go along the graph, we'll multiply all of the quotients as we described earlier, right? So that will be the algorithm. And then now let's write our recursive function compute. So here we have our recursive function. We'll pass in the two variables that we're looking for, the graph, and then the set of things we've seen and the product so far. So first, let's handle our base case, right? So if the query var A is not in our graph, that means if this starting point is something that we don't have in our graph, then we should just return -1, right? So if not contains key var A, return -1, right? So this way, if we have like x over x, it'll just short circuit and return -1. The next thing is our base case. So the next thing is if both of these are equal, right? So if both of A and B are equal, that means we've reached our destination. In that case, we'll return our product so far. So here's that base case. If A and B are equal, we return our product so far. Next thing we need to do is we need to add A to our list of seen or our set of seen variables, right? So that way, we don't visit it again. And then the next thing we'll do is loop through all the children of A, right? So we can recursively look for our destination. So for each child in A, so here's our loop that goes through each child of A, right? We get all of the things that A is connected to, and we get that entry, right? So this will tell us A over all of these things in the map. So now the first thing we'll check is if scene.contains entry.getKey. That means if we are going to a variable that we've already seen before, then we just continue, we skip it because we don't want to revisit the same nodes. Otherwise, what we'll do is we'll find recursively what is the value of this child to B, right? So we'll call this recursive function. Our query var A will now be the child, so it will be entry.getKey. Our B will remain the same because that's our destination. The graph obviously remains the same, and so does the scene. And then the product so far is interesting. So that now we'll multiply the product so far times the quotient of A to this child, right? So the quotient of A to this child will be entry.getValue. So that's the value of the current edge. And then that's now the new product so far, and then we'll recurse with that child up to B, right, to find B. So now if this is not -1, that means we've found a way to reach the B from this node, then we'll just return that value, right? So that means we found B and we'll return it. And after going through all the children, if we still don't find B, then we'll return -1 at the end, right? So yeah, I believe this should do it. Let's run it and see how this code does. All right, accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. Cheers.